Here's the code for directions in crystals. Now suppose you have x, y, z axes, and you have an initial point, A is 0, 0, 0, and point B is 0, 1, 1. B minus A is the vector from A to B. You subtract the coordinates, you get 0, 1, 1. That's most of the way to the notation, but we want to make a very compact notation here. So they do a couple of tricks. First trick is no commas. Second point is to use square brackets. So 0, 1, 1 is the answer for the first example. That's the code for that direction. Second example, C could be the point 1/2, 1, 1/2, and D could be 1, 1, 0. So the arrow from C to D has components given by 1/2, 0, minus 1/2. But we want this to be very compact, so they do a couple different tricks. First is, since we're talking about a direction, doubling the direction wouldn't hurt anything. So we can multiply this whole thing by 2 and get 1, 0, minus 1. And we're ready to put in square brackets, except they want to be even more compact. So instead of putting the minus sign in front like we normally do, they use it as an overbar. So in other words, 1, 0, 1 with an overbar in square brackets. That's the notation for this direction vector from C to D. Finally, we can talk about a family of directions. Directions equivalent to 0, 1, 1 would be 0, 1, 1 in angled brackets. Which directions are equivalent depends on the crystal. In a crystal, those are all the different directions that encounter the same sets of atoms, basically the same pattern. You could rotate the crystal around and it would look the same. So how big this family is depends on the shape of the crystal you have, whether it's cubic or tetragonal or what.